The Nemiverse. Gravitational time dilation.
Hello guys, I'm your host Jay Munchie and this is the Nemiverse. Today's topic is gravitational time dilation. What is gravitational time dilation? Well, gravitational time dilation is a form of time dilation. It is the difference between elapsed time between two different events happening in two different places, being observed by observers situated at various distances from a gravitating mass. The weaker gravitational potential, the further away you are from the clock, is the source of gravitation. Atomic clocks at different altitudes will show different times. This effect detected is such earthbound is extremely small, with differences between measuring in nanoseconds. So relative to the Earth age, about 4.5 billion years ago, the Earth's core is 2.5 years younger than the Earth's surface. Well, one of the reasons why is because when the Earth was first created, in the late bombardment, right, the late Great Bombardment, pieces of rock, asteroids will come together as gravity will actually pull things together and create a curvature. The sphere is due to a rotation of the Earth. Demonstrating larger effects will require greater distances from the Earth or a larger gravitational source like Jupiter, leading to a paradox of alignment with the sphere to rotate. So demonstrating larger effects will require greater distances from the Earth or a larger gravitational source, as like the moon has an effect on our ocean tides. Gravitational time dilation was first described by Albert Einstein in 1907 as a consequence of special relativity and accelerated frames of reference. If my hand moves slow, the slower time will feel. You know how you go to work and then you take a shortcut to work and you get there 10 minutes earlier than you would by taking the longer route? In general relativity, it is considered to be a difference in passage of proper time at different positions, described by a metric tensor of space-time. And what is space-time? Space-time is broken down to light years. When we talk about space-time and Earth time, it's two separate times. We're going to talk about clocks now. So clocks that are far from massive bodies of gravitational potential run more quickly, as to clocks that are close to their massive bodies run at a lower gravitational potential, which will run more slowly. A clock set at the peak of Mount Everest will be 39 hours ahead of a clock set at sea level. If two people start walking, and I'm a tall guy, I'm about 6'3", so I have long legs, then somebody that is about 5'5", okay, or we're going to say close to average height, okay, due to me having long legs, I tend to walk, it seemed like I will walk faster, which I do, because I would take, for every 2 steps somebody take, I could take 1 step will equal 2 of their steps. So in our reality, I would tend to move, I will walk or seem to walk faster than the average walking person. But I had tested this theory before. And if y'all want to see me test the theory with somebody in real life, comment me below and I will do the experiment. But basically, I always tend to walk past a person, especially if we walking out the door at the same time. I tend to, we'll be walking at the same rate at first, but then somehow, if I pick up speed by me walking, and you know, once you get into your pace of walk, you do have a steady pace. I wouldn't say it's really quick. It's just basically your speed of walk due to your weight and gravitational pull as you walk. Interior mass and gravitational mass are equally the same. they accelerate at such speeds. Uniformly rotating reference frame with its proper time dilation are physically equivalent to a gravitational field, a long accelerated spacecraft, a skyscraper, a shaft on a planet. Let there be dependence on a g-force on heights. Just like me, I'm tall. I tend to feel more g-force in my legs than I feel in my head and my arms, my shoulders, my upper body. Total time dilation at a distant position is the dependence of a g-force on a height. Also, it will be coordinated as time between two events between A and B. So with that being said, I hope you enjoyed. This is the Nemiverse. I'm your host, Jay Munchie. Hope the things that I mentioned in this video about gravitational time dilation will help you in your studies. And with that being said, thank you for watching. Thanks.